Hello everyone, this is Chengge Zhang here from Tersus GNSS Inc. Today I will introduce a new software, Tersus Geo Office version 2 from Tersus, explain some of the key features and functionality, and show some of the main operating procedures. Tersus Geo Office version 2 is a Windows desktop software and we just released a beta version last month. Tersus GeoOffice version 2 has many business module functions, such as GNSS post-processing, road design, point cloud display, and so on. Our goal is to build a software that can handle almost all Tersus business on the desktop, and the software is completely designed and developed by Tersus, so has the ability to add new functionality, add more language support, and maintain the software to meet the needs of our users based on their feedback. This is the outline of the Tersus GeoOffice version 2 introduction. I will start with an introduction to Tersus GeoOffice version 2 in general, showing the main interface of the software and menu buttons. Then I will introduce the three major functional modules in Tersus GeoOffice version 2. They are GNSS data post-processing, road design, and point cloud data processing, during which I will show the operation of basic functions. If you have any questions or suggestions about the Tersus GeoOffice version 2 introduction, including if you want to experience the beta version, as well as to get the sample projects in demonstration today, you could contact to our sales or support, and we will carefully read every request and suggestion to help you better understand Tersus GeoOffice version 2 and continue to enhance Tersus GeoOffice version 2. So let's get started with introduction today. Starting with the first chapter, a general introduction to Tersus GeoOffice version 2. What is Tersus GeoOffice version 2 and what are the key features of the software? As we have just described, Tersus GeoOffice version 2 is a new desktop data processing software running on Windows operating system designed and developed by Tersus GNSS Inc. Here on the right is a screenshot of the software. The software includes coordinate system and coordinate conversions. We have added commonly used ellipsoid projections and also predefined coordinate system for many countries and regions. And actually, the number of the predefined coordinate system has been basically the same as in Tersus Nua software, another software used for data collecting running on Android controller. Here in Tersus GeoOffice version 2, the coordinate system and the coordinate conversions were applied to the whole project and all data in the project. We have also added antenna management in the software, which mainly serves GNSS-related functions. We process the antennas of various manufacturers according to the latest antenna information file released by NGS organization. After import the GNSS data, it can automatically recognize the antenna information contained in the data and make calculations based on the antenna data when processing the data. And you can also manually add or edit additional antennas in antenna management. Then there are the business modules that have existed and are planned to be developed in Tersus GeoOffice version 2. The GNSS module is a core function of the software. The post-processing of GNSS static data has been fully realized currently, and the processing of GNSS stop-and-go data will be added in the next version. Road design and point cloud data processing are the special features in Tersus GeoOffice version 2. Road design is mainly used for importing design files, editing, graphical display, and inspection of roads, and then exporting the roads to such as Nua software for field staking of roads. The point cloud data module is that after the data exported from Tersus MVP product and pre-processed, such as track processing, then the point cloud data can be displayed in Tersus GeoOffice version 2. And you could also do some sampling, cropping, or earthwork volume calculation, and so on. I will show the operation of the GNSS post-processing, road design, and point cloud data processing in the demo later. Then in the other version, we have planned to continue to add RTK project processing, in which part NUAS project can be directly imported into Tersus GeoOffice version 2 and the post-processing calculations, as well as UAV, USV, and other more modules. Here we have uploaded the beta version released last month to Dropbox, and I will also paste the download URL link into the comments of this video as well. Just download the exe file from the link and double-click on it, then follow the instructions of the installer to complete the installation. You are welcome to download and try it out, and give us your comments. If you have any questions, you could also contact Tersus at the support email or sales email here. Now let's look at the main interface of Tersus GeoOffice version 2. This is a screenshot of the software. The view window is centered, which displays the graphics. The background color of the view window and the color of the marks, lines can be changed in the software settings. And the data list will also be displayed here if you switch to display such as a GNSS file list, site list, baseline list, and so on. You could check and confirm the information of the data in the list. On the left side of the screen, there is the workspace window, showing all the data in the current project and the relationship between the data. And on the right side of the screen, there is a properties window, showing the properties of the selected item. If you select a GNSS file, you could change the site name, antenna height, and antenna type here. If you select a GNSS site, you could set the constraint coordinates here, as I will also demonstrate later. At the top of the screen is a menu bar and some buttons. Switching different tabs in the menu bar will display different function buttons for different modules. Click on the File tab will show operations of Tersus GeoOffice version 2 projects, such as creating a new project, opening a local project, saving the current project. In the Project tab, you can configure the basic information and the coordinate system of the current project. In the View tab are some buttons for view operations and some tools for distance and angle measurement in the View window. The GNSS tab, Roads tab, and the Point Cloud tab will be expanded later. The Coordinate System Management tools and Antenna Management tools are in the Tools tab. The four buttons at the top are Save Current Project, New Project, Open Project, and Software Settings. So what has changed in Tersus GeoOffice version 2 compared to previous Tersus GeoOffice version 1? The most obvious change, which is also the purpose of developing Tersus GeoOffice version 2, is that version 2 has more functional modules, such as road design, point cloud, and RTK post-processing, whereas version 1 only has the function of GNSS data post-processing. And since the version 1 is no longer maintained and updated, version 2 will have a stronger GNSS post-processing calculation engine, and the iterative development of Tersus GeoOffice version 2 will ensure more functionality and language support. Now let's start the introduction of GNSS part. The configuration of the coordinate system in the current project is very important in the process of GNSS data. I will show how to select a predefined coordinate system, edit the predefined coordinate system, and edit the parameters of the current project in the video below. First, go to Tools, start the Coordinate System Management tool. Here on the left side is a list of selectable coordinate systems. If there is no suitable one, you should go to Add one. Click on the predefined list. Find the target one according to the continents and countries. Confirm the parameters. Click Add. Add it to the selectable list. And if the parameters need to be edited, right-click it. Send it to the customized list. Rename it. Then you could edit the parameters on the right side. And add the modified one to the selected list. Go to New Project. Now you can select your coordinate system in the list. Input the new project name. And if you have created a new project but would like to edit the coordinate system, then you could also go to Project Coordinates. Directly edit the parameters of the current project. Next, I will show the operation of GNSS static data processing. There are several steps in GNSS static data post-processing. First, data import and data check. Next, baseline process and residue process. Then, control point constraint, network adjustment, and report. Now let's see the video. Go to GNSS module. Click the Import button. Select the GNSS static data. Rhinix format and Tersus TRS format are all supported. If you only select the Rhinix O file, the software will automatically read the ephemeris file in the same directory. It will take some time. I will show you the result after data importing. Click on the File List button to check and confirm data information. Site name and antenna information could also be changed here. For example, I edited the antenna of 7776 site. Then click on the Process button to process all baselines. It will take some time, so I will show you a project where all baselines have been processed. In this project, go to baselines list. You can see all baselines are fixed. If there are some baselines with low precision result, select it and open the residue chart. You can see the residue results of each satellite. If there are periods with large residues of satellites, go to Deleted. And then reprocess the baseline, the RMS will turning smaller. You can check the RMS value in the baseline list. Next step, control point constraint. Go to Sites list. Select the control point and input constraint coordinates in the Properties window. Click Apply. And go to Adjustment. Select Auto and click Adjust button. The software will automatically adjust according to the constraint. Click Report to open the adjustment report. Here, you could see baselines information and the coordinates of sites after adjustment. During the above process, if you need to overlay the map, click on the View, Earth View. To see site location on maps. You could zoom, move, or rotate the map with your mouse. It will show you in 3D view. You could also configure the link of the map. For example, switch from Google Map to ArcGIS Map. This is GNSS static data processing. There are many other features are not shown here due to the time. And if you have any questions, please contact us. Next is a demo of road design. This module is a process of digitizing roads. For example, if you get the road data from design organization, you can first digitize the road into Tersus TRD format in Tersus Geo Office version 2, and then import the TRD file directly into NUA for field road stakeout. I will show you the road design and display in the video. Go to Road module. Here, if you have, you could directly import a road in TRD format. Later, we will also support LandXML, DXF format, and so on. The imported road will be shown in the view window. If you only have road parameters but no digitized one, you could also create a new road. Generally, roadways have center line alignment, vertical profile, cross-section, and other parameters. Here, click the alignment to input the parameters of center line. There are two methods of center line input. And I choose the intersection method. Input the coordinate of the intersection point and radius, closoid length, for example. And you will see the center line in the view window. Click the vertical profile. To input the vertical parameters. Meanwhile, the vertical curve will be shown in the view window. If you change the parameters, the curve will be changed. And go to cross-section to input the parameters of left side and right side. For example, a driveway, a green bell, and another one. If the right side is the same as left side, click Set as Left to use the left to override the right. And you can see it. During the process above, you could also click the 3D view in Road module to visualize the road shape in 3D. You could also zoom, rotate, and move with your mouse in 3D view. After checking all road parameters and confirming, click the Export button to export TRD file. Then you can import the TRD road to Nuva software to road stakeout in field. Point cloud processing. The import and processing of point cloud data. The point cloud module in Tersus GeoOffice version 2 is mainly used for LAS file import, point cloud display, and basic editing. In other words, if you export the product from Tersus MVP, you need to use Tersus PPK for track pre-processing and point cloud matching first, and then import the LAS product into Tersus GeoOffice version 2 for operation. Now let's watch the video. If the point cloud need to be imported in a new project, go to Point Cloud module. Click New Clouds. Enter the name first. You can now see it in the workspace. And click Edit button to open the point cloud window. Click plus button here to select LAS file and add the file to the file list. Then click plus button to select the field in the LAS file to import point cloud data into the software. It's going to take some time, so let us wait for a few seconds. The point cloud module is a bit more demanding on the computer configuration compared to GNSS post-processing and road design. And with a better configured computer, the point cloud will be loaded faster and be processed more smoothly. Now the point cloud data has been shown in view. You can move, rotate, and scale in view with your mouse. There are some basic functionality of point cloud processing in the current version of Tersus GeoOffice version 2. For example, there is a house here in this point cloud data. And I want to extract the house part to do volume calculation. Select the data, click Editor. First, mark on the point cloud to get the coordinates of point mark. Double-click on it. Now I get the XYZ coordinates. Secondly, add a selector. Add the box selector according to the XYZ coordinates. Input the value. And in the view window, it also shows the selector. I will remove the outer of the selector. And now the house part is remain. Next, I will show you how to do volume calculation. If you need to calculate the volume, a DTM mesh, such as tin, must first be generated. So that the volume of each triangle cone between the house surface and the design altitude surface can be calculated. Click Make DTM Mesh. Now you can see the DTM mesh both in the dialog and the view window. Click Add and select the boundary points in the view window. You can rotate, zoom, or move the point cloud to make the point easier to select. Double-click the boundary points and select. You can input the design altitude, design fixed altitude, and click Calculator. The fill part will be shown in the view window. In order to better display the fill part and the cut part, I set the design altitude to the average altitude of the boundary points. And now in the view window, you can easily see the design altitude surface and the fill cut parts. Okay, this is the whole content of Tersus Geo Office version 2 introduction. If you have any questions, welcome to contact us. You can also write a comment under the video. Here again is the beta version download link and emails. Thank you all. Thanks very much.